let's look at this problem right here. It says you walk into GameStop and pick up a new controller for $29.99, a game for $49.79, and a PlayStation 3 for $219.19. To the nearest dollar, how much is the total cost? In this particular problem, would they be looking for an exact answer? Yes, they would. Because they're saying to the nearest dollar right there. So that implies that they're looking to round in one particular way. But a lot of times when you estimate, you don't have to do it that way. And they're looking for you, whenever they ask for a total, that's going to usually lead you to an addition problem. That's what we have here. So let's pull out the key pieces of information here. They spent $29.99 on the controller. They spent $49.79 on the game. And then for the system itself, it cost $299.19. By the way, anybody who wants to challenge me in Madden, I was a pretty good player back in the day. My video games skills have declined just a little bit, but I can still hang in there. If you want to put that in there as a goal or something like that for you to do, I'll definitely challenge you at some point during the year. So we have $29.99. If I was to round that to the nearest dollar, well, the nearest dollar is this 9 right here, right? It's the nearest ones place. If I look to the right of that 9 right there is going to tell me to round up. So I'm rounding up. This would become 30. Because that 9 right there, it's going to turn into a 10. And rather than say 2 with a 10 on it and make it look like $210, we don't want to do that. We make this $30. We do the same thing here. I'm looking at the 9. Right over to the right there. You like that little background noise? We got 50. That becomes 50. And then same thing here. Just because it's a 3-digit number doesn't mean I'm still, I'm going to go away from looking at the ones place. So I look at the ones place again. And to the right of the ones place here is a 1. So I'm actually going to round down here. So that's going to be $299. And just as a little heads up, if you were in the store, you'd probably call this $300, but they said to round to the nearest dollar. Just as a little heads up here, when you're rounding 0 to 4, if that's the number to the right, like it was right here when there was a 1 there, you're going to round down, and then 5 to 9, 5 is considered like the breaking point. That's where you round up. And the reason 5 is considered the breaking point, there's 5 digits, 5, 6, 7, 8, and 9 that you can round up. And then there's 5 digits you can round down, 0 being one of them. That's the one people always forget about. 0, 1, 2, 3, and 4. So there's 5 digits that you can round down and 5 digits that you can round up. That's kind of the way it works. So if we're rounding this to the nearest dollar, like I said, total is usually going to be you're adding. 0 plus 0 plus 9 is 9. 9 plus 5 plus 3 is 17. And I carry that 1 up there. So the total cost would be about $370. And we always want to put these in a complete sentence, so mine just says exactly what I just said. Alright, let's look at the next one. Amanda and her family are driving from Boston to San Diego. The distance of their trip is 2,577 miles. When they go to Lincoln, Nebraska, which is 1,499 miles from Boston, about how many miles do they have left? And we're going to round this to the nearest 100. So again, it's kind of asking for an exact answer. So we look at 2,577 miles. If we're rounding that to the nearest 100, that will become 2,600 miles. And the reason for that is I'm looking at the right of my 5 here, and to the right of the 5 is a 7, and that 7 is always going to tell us to round up. And then we have Lincoln, Nebraska down here, so again I'm looking at the hundreds place, that's what we're rounding to. And to the right of that is a 9, so this number becomes 1,500. And notice everything to the right of the place value that I rounded is a 0. That turns to a 0. And everything to the left of the place value that I rounded will stay the same, with the exception of, on that last problem, you saw that when we had the 9 here, the number to the left actually moved up 1 to 30. And that's because the 9 kicked it up. We carry the 1 there. But usually the numbers to the left are going to stay the same, and the numbers to the right are going to become zeros. And in this problem here, since they have driven from Boston to Lincoln, and they're that far along in their trip, we're going to subtract here because they don't have we're not adding these miles up. They're not doing it twice. They're not going back and forth. So we got to subtract here. So our subtraction leads us to believe that this would be, 1,100 miles left in their trip. And that's kind of fun to do if you ever bothered mom and said, are we there yet? Are we there yet? She can say to you, we have about 1,100 miles left. Maybe you can say that to your little brother or sister this time instead of bothering mom. All right. This time we have the 6th grade. They're planning a trip to Prince Pizza. That's a fun time. We did that last year, I think. The teachers expect 211 students to attend. So about how many tables will Prince Pizza need if they can only fit 6 students at each table? Prince Pizza, by the way, they can fit more than 6 students at each table. I think they can fit 12 or 14 at each table. But anyway, if we have 211, this is a division problem we got going on here. So 211 divided by 6 is pretty much what we're doing. Now, I don't know if 6 will go in there evenly or not, but I want to give something that's really easy to do in my head. So I want to cover up this 1, sort of pretend it's not there. Would 21 divided by 6? It wouldn't, right? 24 would, or 18 would. So you know what I'm going to do? I'm going to change this 21 right here to 24. And I'm going to turn that 1 into a 0. And I'm going to leave 6 the same. So all I'm doing really is dividing by a number that I know 6 will go into. And that's called finding compatible numbers, numbers that go together. 21 and 6 aren't compatible because 6 won't go into 21 even. 6 and 24 are compatible because 6 will go into 24. Or in this case, 6 and 240 are compatible. And as hopefully we know by now that if we add a 0 to the end of that 24, no big deal. We're just going to add a 0 to our answer. So they would need about 40 tables. All right, one more problem here. It says the weight of a humpback whale is about 41 tons. That's a lot. A ton is 2,000 pounds. So just think about that. A marine biologist claimed that she once saw 19 in one day. About how many tons would those whales weigh together? Say that 10 times fast, right? If we have 41 tons and she saw 19 in one day, it says about, and whenever you see the word about, of course, that means you can use an estimate. And they're just trying to give you a quick number here. So when you estimate in this problem, we're doing actually multiplication. Hopefully you picked that up. When you do multiplication, you can actually do a couple of things. You could change 41 into 40 and do 40 times 19 if you know how to do 4 times 19 fast. That's one estimate. You could take 19 and change that into 20 and do 20 times 41 if you know how to do that fast. I think the easiest way actually is to change both 41 and 19 in this case. So I would change 41 to 40. I'm just rounding it down because that's pretty close by. And I'm going to round 19 up because that's pretty close by. And I would have 40 times 20. So how many tons did she see together? That would be about 800 tons that she saw in that one day. 4 times 2 is 8. With the 2 zeros makes it 800.